Across the world, massive buildings are being constructed. It's not for offices, for apartments, or even for people. They are being built for machines. Inside these facilities are rows of powerful processors, endless cables, and cooling systems running day and night. Entire structures are designed for one purpose only: to generate more computing power than ever before, and almost nobody outside the tech world is talking about just how fast this is happening. For decades, computers followed a simple rule: smaller, faster, cheaper. Every year, devices become more compact while gaining more power. A phone in your pocket today can do things that once required an entire room of equipment. But modern technology has outgrown that model. Today's systems analyze behavior, predict outcomes, generate content, and manage massive networks of information. Every search result, every recommendation, every digital service you use depends on computing power working behind the scenes. And the demand for that power is exploding. Every time a new digital tool becomes popular, it increases the need for faster processing. Every time businesses rely more on data, the machines handling that data must grow stronger. Every time technology promises instant results, the infrastructure supporting it must expand. Small computers are no longer enough, so instead of making machines smaller, companies started making them bigger, much bigger. Today, some of the most advanced systems in the world are built at an industrial scale. Entire warehouses filled with processors working together, massive facilities that consume enormous amounts of electricity just to keep everything running. Cooling systems are designed to prevent overheating, as thousands of components operate at full capacity every second. This is about building the backbone of the modern digital world. In the past, countries competed over natural resources: oil, steel, and manufacturing strength. Those things determine power and influence. Now, computing power is becoming just as important, because the ability to process information quickly shapes everything else. The organizations that control the most powerful computing infrastructure often move faster, innovate quicker, and respond to problems more efficiently than anyone else. So a quiet global race has begun for processing power. Some companies are building massive networks of processors, working together in giant data centers. Others are designing unusually large and dense processors that challenge traditional limits of chip design. Different strategies, same goal: more speed, more capacity, more capability. But why such urgency? Because modern digital systems are hungry. They consume enormous amounts of processing power to function smoothly. And as people expect faster responses and smarter tools, the machines supporting those expectations must grow accordingly. Every improvement in technology creates even greater demand. Better tools lead to more usage. More usage requires a stronger infrastructure. Stronger infrastructure enables even more advanced systems. It becomes a cycle that keeps accelerating. But as these machines grow larger and more powerful, something else is happening. They are becoming harder to fully understand. No, they're not mysterious. They are incredibly complex. Modern computing systems are no longer single devices. They are vast networks of hardware and software working together simultaneously. Thousands of components operating in coordination, processing information at a scale far beyond anything early computers handled. No single person can hold the entire system in their mind at once. Teams of specialists design individual parts, each focusing on a specific area. When everything comes together, the result is a machine of immense capability and immense complexity. This doesn't mean we've lost control. Humans still design and manage these systems, but the relationship between people and machines is evolving. We are moving from tools we fully understand to systems we trust to function correctly. Similar to how people trust airplanes without knowing every mechanical detail, or rely on power grids without understanding every connection. Trust replaces complete understanding. And as computing power becomes more central to daily life, that trust becomes essential. Most people will never see the giant machines being built today. They operate quietly in the background, far from public view. Yet their influence touches nearly everything, from the services we use to the systems that keep cities running. These machines help businesses make decisions faster. They support research that leads to new discoveries. They manage networks that connect millions of people every second. In many ways, they are becoming part of global infrastructure, just like energy grids or transportation systems.